Now let's do a couple of examples. Not by definition though. So let's find the equation of the hyperbola with foci at 4, 0 and negative 4, 0. And the difference of focal radii is 6. Now, if I remember from the information, the difference of the focal radii is twice the a value, which means that our a value is 3. And the c value is going to be the distance from the center to a focus, which in this case is 4. And how did I know it was 4? Well, because the midpoint of the line segment created by the foci is the center, and the midpoint between 4, 0 and negative 4, 0 is the origin. So I know I can go from the origin to 4 or negative 4 on the x-axis with a distance of 4. So c equals 4 and a equals 3. And now I need to know that fundamental relationship, which is b squared equals c squared minus a squared. And so then I get b squared equals 16 minus 9, or b squared equals 7. So I have b squared, I have a, which are the two numbers that I need for my hyperbola. And so now all that's left for me to do is figure out if this hyperbola is an x squared minus y squared or a y squared minus x squared hyperbola. And so I think about how the foci are oriented. I have a negative 4, 0 as one focus and a 4, 0 as my second focus. And since this is horizontally aligned, the horizontally aligned foci always yield equations that are x squared over a squared minus y squared over b squared equals 1. And remember, the a and the b for the hyperbola don't swap. It's just the x and the y that swap. And so now I have my a, which is 3. So this hyperbola has x squared over 9 minus y squared over 7 equals 1. And if I were to have to graph this hyperbola, I know where the asymptotes are going to be. They're going to intersect at the origin because that's the center of the hyperbola. And its slope is going to be the square root of 7 over the square root of 9, because remember, it's change in y over change in x for your slope. And for a second example, let's find the equation of the hyperbola with foci at negative 5, 0, 5, 0, and asymptotes at y equals plus or minus 3/4 x. And to find the center, I have to find the midpoint of the line segment with endpoints at negative 5, 0, and 5, 0. So the center is once again at the origin. And with the center at the origin, that means my c value in this case is going to be 5. Now, knowing that my foci are oriented horizontally, and I know I'm going to have a hyperbola that looks like that, I know that my equation has to be of the form x squared over a squared minus y squared over b squared equals 1. And now I need to use this information from the asymptote. And remember, the slope is always change in y over change in x. And so the change in y over the change in x is going to be 3 over 4. Now, technically, it simplifies to 3 over 4. So this could be 6 over 8 or 30 over 40 or some other numbers, which is why we need the location of the foci. Just having the asymptotes alone isn't enough, because the asymptote just tells me the change in y over change in x. It doesn't actually tell me what x and y are. Now, I know I have some multiple of 3 is b, and some multiple of a is 4, and this is when I use that b squared equals c squared minus a squared. And in this case, I don't have to actually do the math because I have 3, 4, and 5, which is a Pythagorean triple. Had this been 10, plus or minus 10 as my foci, then I know this is not going to be a 3 and a 4. It would have to be a 6 and an 8, right? So you can't just look at the asymptotes. You need the foci to pinpoint the exact value. Because remember, this is just the ratio of the a value and the b value, or in this case, the b value and the a value. And so now I know that since I have a 3, 4, 5 triangle, I know that indeed b, the change in y, is going to be 3, and the change in x or a is going to be 4, which gives me the equation x squared over 16 minus y squared over 9 equals 1. Finally, we're going to talk about shifting the center of the hyperbola. And shifting the center is just like shifting the center of a circle or of an ellipse. You take x minus the h value and y minus the k value to shift that center away from 0, 0. Everything else stays the same. Same thing with the vertically aligned foci. You shift the center by subtracting h from x and k from y and putting it in parentheses and squaring it, just like you did for the circle and for the ellipse. Finally, let's find an equation of a hyperbola with a shifted center. So the foci are at -3, 2, and -3, 8, and now we have a difference of focal radii of 8. All right, now let's figure out that equation for that final example with the shifted foci and shifted center. My difference of 8 gives me my a value, so I know that 2a equals 8 or a equals 4. And in order to find b, I need to know the c value, and I find the c value by analyzing the foci. So focus 1, which is at -3, -2, and then I have focus 2, which is up here at -3, 8. So that tells me I have a hyperbola that's oriented in that fashion, which means that my foci are vertically aligned. And when I have vertically aligned foci, that means I have the y squared minus x squared version of the equation. And so I need to find this point, which is the center of the hyperbola, meaning the midpoint of the line segment whose endpoints are -3, -2, and -3, 8. And it's going to be -3, comma something. Going from 8 to -2 is 10 units. Half of that is 5. So at -3, 3, I have my center. And my c value, which is the distance from the center to a focus, is going to be 5. So I have c equals 5. C equals 5. I have c equals 5. And so I know that my equation has to start y minus 3 squared over 16 minus x plus 3 squared over something equals 1. Because remember, for the hyperbola, it's always a squared and then b squared, and I know a is 4, and so I can just put the 16 there. And if it's vertically aligned, the y's go first, the x's are being subtracted, and then the center is just y minus the y value and x minus the x value. And so now all I have left to do is to find the b value. And I find the b value by remembering that b squared equals c squared minus a squared. And so b squared is equal to 25 minus 16, which is 9. And so therefore, underneath the x plus 3 term, I have my 9. And so this is my equation for my hyperbola.